Hi, everyone. Thanks so much for joining us today, and welcome to Steam Management's webinar series. Today, we're going to dive into how Steam is used across various industries, explore efficiency opportunities, and take a look at what the future of Steam might hold. Our host is Chase Bean, Steam Management's Vice President of Revenue and Engineering, who has over 16 years of experience in engineering, project management, and business development in the energy sector. Feel free to ask questions in the chat at any time. We'll do our best to answer them as we go, and we'll also leave time for a Q&A at the end of the session. Thanks again for being here, and with that, I'll hand it over to Chase.
Thank you, Ashley, and thanks everybody for joining. We are Steam Management. We're an EPC energy efficiency contractor that offers sustainable solutions for steam and other utility systems. Basically, we provide turnkey retrofit projects with a focus on efficiency improvement, and our solutions reduce system energy costs, conserve water, and reduce carbon footprint for our clients. I'm Chase Bean. I'm your presenter today. Also, PDH certificates are available upon completion of the webinar, and you just email me at that email address there. And our past webinars and this webinar will, once it's completed, will be available at steammgt.com/webinars. The learning objectives today. So we're going to understand STEAM applications across various industries. We're going to identify some steam using equipment and typical roles. We're going to recognize typical applications and efficiency opportunities across facility types. First of all, why steam? Steam, everybody knows in certain facilities, steam systems are getting retrofitted, but steam as an energy carrier, as a heating medium or an energy medium is still a great option. There's a high heat capacity per mass. It's easily sourced, so it's water instead of a processed chemical or something that means. And it's versatile across industries, adaptable to numerous applications, tried and true technology, been around a long time. It provides high temperature, so when you get to certain temperature needs for processes, there's really few alternatives. It's also efficient for heat transfer and has a low environmental impact as far as leaks or needing to purge your system. It's just water, so you can just drain it out. Okay, now we'll go over some steam-driven equipment and have some photos of a lot of those so you can kind of see what we're talking about here. First of all, in HVAC and space heating, you have steam radiators. These are typically used to just directly heat spaces through radiation in a building or in a room. They're typically found in older buildings and residential buildings, and used for heating rooms in schools, offices, and historic buildings. They're sized based on their EDR, just so you know, so that's equivalent direct radiation. So you can go around an old steam heated building, summate all of the EDRs for all the different units, and use that to determine or estimate the building's heating load. The manual steam valve there for the radiator is circled in red. I just wanted to show that or highlight that quickly because we'll talk about thermostatic radiator valves a few times, which is an opportunity to modulate the steam flow to these units automatically based on the space temperature, which is a good efficiency opportunity. Next, you have unit heaters. So these are basically like a coil with a fan. It blows air over the coil to heat large open spaces. You'll see these in warehouses and garages. They're great for rapidly heating like poorly insulated areas or drafty areas. You may hear these referred to as steam modines. It's like a brand name. It's kind of like calling a copy machine a Xerox. But yeah, we generally refer to these as unit heaters. And you'll see these gas-fired and electric ones as well, but this is a steam-based unit heater. This is a fan coil unit. Basically circulates air over a steam coil to control temperature as well. This is similar to a unit heater. However, this is more for like inside the occupied space of a building. Typically has more sophisticated controls, can be integrated into the building management system. So it's kind of a similar idea as far as blowing air over a coil, but a little bit different, category of equipment. Then next you have coils and air handling units, rooftop unit shown here, UV coils. This is an open UV coil. You see these in classrooms a lot. Often there's a UV and a radiator in a classroom. And these allow outside air in as well. Again, have a fan coil or a fan blowing over a coil. Often have a heating and a cooling coil in them, and another steam user. This is a steam convector. These are typically the coil is fin tubes, so this one's open, so you can see that in there. Usually do not have a fan. I mean, that's what kind of makes them a convector instead of like a forced air type of unit. So these are also often found in classrooms and hallways and things in a steam building. Humidifier. So a lot of facilities use steam in air handlers or in other places to maintain the humidity. Often you'll see this in healthcare as the humidity levels, promote like a healthy environment for the patients. You have in brewing and labs and clean rooms that have kind of specific humidity requirements. This is a steam to hot water converter. So these are used for hydronic heating. You'll often see these in facilities that have steam for other processes, but want to use hydronic heating instead of steam heating. Or you'll see them in steam buildings that have annexed a new section of the building, and they will have a steam to hot water conversion, and the new section of the building will be hydronic. Steam to hot water can also be used for like domestic water heating or non-domestic water heating. Here's another steam based hot water heater, and here is another steam hot water heater. Now on to process heating. So you have steam jacketed kettles, which indirectly heat and mix products using, steam filled jackets around like a kettle or tank. You have process line tracing or jacketing, which maintains fluid temperature or prevents freezing in pipes. And that's what's pictured here. So these sections of the piping, they have basically an inner pipe and an outer pipe, and in between the pipes is like a steam jacket to maintain temperature. This is actually process piping, and this is product is being maintained at about 180 degrees. And if you picture underneath this insulation at the end, these two pipes converge so that you have a welding point. So this elbow has a cavity separate from this piping cavity, and that's why you see these little jumpers here. And so for every intersection or every valve, you have to have a jumper so the steam can continue to flow through the system. You'll also see steam tracing just for freeze protection, which is a little bit less involved, but maybe just a steam a tube that's underneath the insulation separate and not an actual, double walled pipe. But yeah, that's a common application. You have them in you use steam in retorts for cooking or sterilizing, direct steam injection. You have batch or continuous digesters like in a lumber or a paper mill for breaking down raw materials. You have extruders that will have, phases of heating and cooling to maintain a temperature while the product's being extruded. There's steam heated rollers, blanchers and peelers, oil fryers that heat the oil using steam coils, soaking or steam vats. We're skipping some pictures here. There's the extruder. So you see these different stages of the unit for heating and cooling. Soaking or steam vats. This is a log vat that's used in steam. So they close this door. They heat this space, and the logs sit there for 12 hours or so. And then the wood is soft and can be kind of shaved down for plywood or veneer or whatever they're making. Laundry facilities use steam for washing, pressing, sanitizing linens, etc. And now on to power generation. So obviously, Steam is used in steam turbines to generate power, whether those are turbo alternators or turbo expanders. They're steam driven drives, like you see here. This is a boiler feed water pump actually that has a turbine attached to it, a steam turbine attached to it, just for the mechanical drive of the pump. Steam is used in presses. Um, this one is actually hydraulically pressed, but then the steam is used to heat the product while it's being pressed. And then, of course, reciprocating drives, which the best example of this is an old locomotive, and you can see that piston reciprocating there, that shaft rather. Sterilization, cleaning, and sanitation. Um, Steam is used in autoclaves and sterilizers, steam cleaning guns and lances, sanitation steam hoses, and steam washers. Drying and dehydration. This may seem counterintuitive if you haven't thought of it before, but even though steam is made of water, if it's really hot, it can dry out product or whatever you're trying to dry just by evaporating the water within that product from its heat. So this is a common application. You have rotary drum dryers. This is a drying chamber. We actually put this valve in, and this unit is as big as the building, so it's hard to get a picture of the unit itself, but we're standing on top of it there in this picture, where they're drying out lumber as part of their process. Here are some steam heated drying rollers. So the paper is going over these rollers, which are heated on the inside by steam, and this paper just dries out. I think it's going left to right here, but it dries out as it goes through that series of rollers. Oh, and then you have conveyor dryers as well. Okay, so facilities overview. So we'll talk about some facilities that use steam. This is not an exhaustive list, but I guess just what we consider to be the most common facilities that we see with steam systems. Steam is used in commercial and federal buildings. It's used in K through 12 education. I've made this category of central generation, where you have a boiler that's feeding a multitude of buildings through a distribution loop. And you see that in higher education, district steam applications, and military bases are three good examples of that. Healthcare, which can also be a central generation kind of facility, but healthcare is another category there. Pharmaceutical manufacturing, brewing and food processing, textiles and laundry, lumber, pulp and paper, and chemical and petroleum processing, as well as power generation, and a multitude of other manufacturing types as well. A lot of manufacturers have heating requirements and will have boilers, but I would say as a just major categories, this is a pretty decent list. I'm going to go through some common efficiency opportunities, which are really applicable at most facilities. So I didn't want to just repeat these over and over. So I'll mention them here. So number one, at really every facility is steam trap maintenance and optimization. Steam trap testing. All facilities that have steam have steam traps all over the distribution and at the point of use, and those traps fail and need to be repaired, and generally that needs to happen once a year or once every couple of years, depending on the application, but that is a really good efficiency opportunity. Pretty much always works, and everybody that has a steam system needs to be doing that. Next is repairing leaks to atmosphere. Again, you are just wasting steam, so obviously those need to be addressed. Pressure reduction is a good opportunity. If you can reduce the pressure in your steam system, you basically reduce your energy losses. If you can do the whole system or just a section of the system, any losses through your pipe walls, like thermal losses, are reduced because now you're at a lower temperature. So there's lower differential temperature between the pipe and the ambient. You're reducing losses through traps because you have less pressure to push that steam through the trap. You're reducing losses and leaks, and it basically just reduces energy loss across the board. If you can actually do it in your boiler, then you're now reducing your boiler feed water pump energy requirements and your gas use, because you're now requiring less energy to get up to a lower temperature set point or pressure set point. Insulation is a good opportunity. Obviously, anything that's uninsulated is wasted heat. Most of the components in your steam system could do to be insulated, with the exception of you have to think it through for condensate tanks, as it can cause cavitation issues in the pump if you're insulating those. But anyway, that's another one. Isolating or demolishing abandoned or unused steam lines. So like we're talking about with the pressure reduction, just having sprawling systems of lines that really aren't being used anymore. That's a big waste. You're getting waste to your steam traps, your thermal wall, or your pipe walls rather, thermally, leaks, as well as like simmering safety relief valves. Just it's just a lot of loss that could be avoided. Condensate recovery, every bit of condensate that you're able to capture and reuse in your boiler is energy that is conserved, as well as clean water that's conserved. So you're introducing less deposits into your boiler, and minimizing your water treatment costs, minimizing your blowdown in your boiler, and minimizing your fuel requirements. Heat recovery, any opportunities for heat recovery, these can be kind of customized opportunities, but often are opportunities at a lot of facilities. Optimizing your boiler operation, like boiler tuning, or other means of improving combustion efficiency, boiler controls, or fuel utilization, or boiler sequencing. All of those are worth evaluating at most facilities. Um, Steam system audits. So having an expert come in and audit your facility and identify what opportunities you have. This can be beneficial to most steam system owners if they haven't had that done recently. Process integration and load matching. So coordinating steam loads and the timing of those loads to avoid inefficiencies like short cycling in your boiler. So having your boiler run full out for periods of the day, and then having it run below its minimum capacity, that can be a lot of waste. Every time your boiler if your steam demand is lower than your boiler's lowest operating point, your boiler is going to short cycle. And every time it cycles, it has to purge air through the boiler, and that's just wasted heat, just air cooling down the boiler for no real use of that heat. So that's to be avoided. So you can get a lot of energy savings just by integrating your processes with your boiler capacities and run times. Variable frequency drives on pumps and fans in the steam system is a good opportunity. And then training and awareness. So one of the best opportunities is always to have a competent boiler operator, or maybe already have a competent boiler operator that could learn even more about how to operate the system efficiently, identify leaks and other efficiency opportunities, and kind of stay on top of those. Facility types. Okay, so we'll go into different facility types, talk about the uses of steam that happen there, and kind of talk about efficiency opportunities and the outlook of the future of steam at these facilities. Commercial and federal buildings first. So typical uses of steam: space heating, we talked about, domestic hot water generation. They can be used in kitchen operations, laundry operations, and then some of these facilities may have cogeneration systems where they're generating some power. Efficiency opportunities, again, we've already talked about all the common opportunities, so these are more specific ones that we're seeing. So thermostatic radiator valves, any building that has heating steam with radiators could use thermostatic radiator valves if they don't already. If they have manual controls or broken operators, that's a good opportunity. Steam boiler replacements, hot water boiler replacements, terminal unit replacements or refurbishments like AHUs, RTUs, or UVs, or either replacing those with higher efficiency units or refurbishing, like updating controls, updating or cleaning coils, and just kind of fixing those up. DDC control valve retrofits as well. And the future of steam rating for commercial and federal buildings, we're giving this a 5. So there is decreasing demand. Modern buildings favor hydronic or electric heating over steam. Energy efficiency goals of buildings. So the trend for high efficiency buildings is to move away from steam. Although it is possible for steam to achieve very high efficiencies, that's not the optics. Right now, everybody's kind of moving towards hydronic or heat pumps. And also high energy efficiency ratings such as LEED ratings. It kind of enhances the uh, perception of the building and actually leads to increased revenue. So there's a lot of motivation to have efficient buildings. And so that's kind of leading to the decline of steam. There's maintenance challenges that people consider, steam systems to have more maintenance challenges than some of the other systems, although that's not necessarily true. That's the perception. And then, steam systems are kind of limited to existing buildings. So steam heating is here to stay in a lot of older or historic buildings, maybe due to replacement costs. But in new constructions, it's not something that people are putting in. Next is K through 12. So similar to commercial buildings, steam is used for space heating, domestic hot water, food service, and cafeteria operations, sterilization and cleaning, and humidification. Same efficiency opportunities, basically, like you would have in a heating system. And the future of steam rating also a 5, kind of same problems. I would say that some of these K through 12 schools are maybe a little bit more ingrained or here to stay than some commercial buildings, but still they're constantly getting converted to hydronic heating and other heating methods, and so a lot of steam systems are getting retired. Next is central generation. So this is like a higher ed, district heating, or military facilities. For all these, you have basically a central steam plant that is supplying steam to the various buildings on the campus for various uses. And like in higher ed, you're talking about classrooms, labs, and administrative buildings. They may use it for heating hot water, laboratory needs, sterilization, humidification, all those things. So steam distribution allows for an efficient supply of heat for all of the buildings on the campus. This is district heating. So in district heating, basically have a centralized steam generation and supply as a utility. So all of the buildings pay the district utility for their steam, just like you would pay for natural gas or electricity based on their use. This is common in urban areas, industrial parks, and campuses, and basically meets all the building needs while eliminating the need for individual boilers in each building. So all of these buildings get to just pay for the steam instead of having to worry about having boiler operators and doing that boiler maintenance and all. Then similarly, military installations. Now they're normally going to own their own generation station. That's not always true, but often have their own centralized steam plant that supports heating in the barracks, dining facilities, training centers, and other buildings. They also use it for laundry and kitchen services as well. The efficiency opportunities here, steam trap monitoring and analytics. So this is where steam trap monitoring starts to make sense for a lot of these facilities. The distribution lines can be higher pressure. You can have larger traps with more potential steam losses when they do fail. And so this starts to become an opportunity. Thermostatic radiator valves in the different heated buildings, steam heated buildings. You have fuel switching and hybridization, so you can incorporate other fuels like biomass or renewable fuels or combined heat and power systems. Excuse me. You can also develop centralized steam system optimization strategies for large scale energy production. If they do have combined heat and power, you can upgrade steam turbines to control grid demand response programs. There's steam district-wide steam pressure management systems, and then retrofitting district heat exchangers with advanced heat recovery. So basically replacing equipment with higher efficiency equipment. Decentralization is also a common thing here. So just taking some of the more efficient users or maybe the more remotely located buildings where there's more distribution losses and decentralizing some of those loads. So future steam rating here, we're going to say a 7. Steam remains a good choice for urban industrial heating networks due to its capacity and reliability. Central generation opens the door for advances in generation technology. So you have basically one large boiler replacement project versus many small replacements. This is really advantageous as new technologies emerge, like, say, industrial heat pumps, which we're going to talk about in our next webinar, or biomass boilers, or maybe renewable energy sources that then use electric boilers to generate steam. So again, steam as a medium is not a bad thing. It's just the fossil fuel generation of it that some people are trying to go away from. And as there's new generation technologies, these central generation facilities are kind of primed to take advantage of those since they have the sprawling distribution systems already. And it remains a good choice for large campuses that have both heating and process needs. But I will say decentralization is a trend in some of these facilities. So we're giving it a 7. Healthcare. Uses of steam in healthcare. We have autoclaves and sterilizers. So you have high pressure steam for instrument sterilization. Steam washers and disinfectors you use to sanitize linens and reusable devices. Then you have steam guns and hoses for surface cleaning. In the HVAC systems, heating and HVAC, again, you have all the space heating equipment, radiators, convectors, unit heaters, AHUs, fan coils, etc. More important in hospitals and other types of buildings is humidification for operating rooms and patient areas to promote, recovery in a healthy environment. Domestic hot water is a common use here. So they're providing hot water for sinks, showers, and restrooms. Food and laundry service. They use steam for steam kettles and cookers for food prep, as well as for laundry operations for washing and pressing linens. And some of these hospitals have cogen facilities where they're producing electricity and using the steam also. Efficiency opportunities here, steam trap monitoring. This is, again, a big one, and healthcare is probably one of the spaces that we see this the most. They just have higher pressure lines. They have sprawling steam systems, a lot of different users, a lot of different steam traps. Generally, maybe a maintenance crew that's stretched thin, and steam trap monitoring kind of gives them more insight into the health of their steam trap population and what needs to be addressed. And when I don't know if I explained this already, but when I talk about steam trap monitoring, talking about like a monitor on each trap that will indicate whether that trap has failed. So it enables the maintenance team to be able to more quickly address those failed traps and minimize losses, but it also helps maintain pressure in the system and proper operation of equipment. As well as reducing water, like when a trap fails, you get water hammer in your condensate system. You also have condensate pumps will start to burn up from having too much heat in the tank that they're pumping. So I could go on about it, but there's a lot of problems from failed traps. So sterilization and sanitation, you can automate cycles and optimize distribution to reduce steam usage. In heating and HVAC systems, you can automate steam control. Domestic hot water, you can use higher efficiency steam to hot water converters. There's newer technology that actually subcools condensate and gets more heat out of it before it returns it back to the boiler room. You can implement flash steam recovery. In food and laundry services, you can upgrade equipment with more efficient equipment, can combine loads to try to smooth out your demand. And then power generation and backup, basically, you're talking about optimizing the efficiency of those units and monitoring performance. Again, this is outside of the common opportunities that I talked about before. Future of STEAM in healthcare, we're saying an 8. There's just a variety of uses in healthcare. It just continues to play such a key role in the facilities. And because of that variety of applications, even new hospitals are putting in, if you're putting in a new hospital, you're going to have a STEAM system often, or most of the time. We do see newer facilities move towards decentralizing some of their loads, but generally there is a healthy steam system at most hospitals that's not going anywhere. Pharmaceuticals, typical uses of steam, again, sterilization, cleaning and sanitation, humidification. So there's kind of stringent requirements in clean rooms and labs at pharmaceutical manufacturers. Obviously used for building heat, but also process heating. There's reactors, distillers, and dryers that it uses that use steam. There's clean in place systems that clean pipelines, tanks, and equipment without needing to be disassembled. So it's kind of streamlined processes. There's steam jacketed vessels, all your air handling units and other HVAC requirements, and then water sterilization. So often in pharmaceuticals, you have water that's purified for injection into the product. And as you can imagine, there's stringent requirements there. Efficiency opportunities, steam trap monitoring again, but this one is particularly, I wouldn't say more than healthcare, but pharmaceuticals is also a particularly good opportunity for steam trap monitoring. These facilities usually have high run hours. They have high pressure lines. They have sprawling steam systems with a lot of traps, and again, maintenance crews that might be stretched thin, and critical processes that require properly functioning steam traps. So this is a really good application for steam trap monitoring. Automating steam supply and batch for batch and clean in place processes, recovering and filtering condensate for reuse in high purity systems, tuning process controls, and installing steam flow metering at key process points. You can't manage what you don't measure. Steam rating basis here is, or steam score, first of all, is a 9, and the basis for that is it's just steam is so reliable for sterilization, their process heating, they have all these clean in place systems that are just critical, and it's versatile for all the different manufacturing processes that they have, as well as they have strict compliance and validation. So it's a reliable way to sterilize equipment, sterilize sterilize water for injection, all those things, and there's really just not a better option. And so you'll continue to see steam systems in pharmaceuticals, for the foreseeable future. Brewing and food processing. So in the brewing industry, steam is pretty integrated into the process. You use steam for mashing, which is where you heat the mash to specific temperatures to convert starches into sugar. Boiling the wort is steam jackets around kettles or internal steam coils will heat the wort to boil it and kill bacteria. Pasteurization is where steam is used to heat beer to a specific temperature that kills pathogens and extends the shelf life of the product. Cleaning and sterilization. Again, they have clean in place systems, which speed up the efficiency of kind of turning over equipment. Keg and bottle washing, and then heating processed water as well. So, and then in the food industry, you have cooking and boiling. Steam's used for cooking and boiling. Extrusion, like we saw earlier, on that extruder. Sterilization and pasteurization. Direct steam injection. Drying and dehydration. Cleaning and sanitation, and humidification. There's often requirements for certain humidity levels in certain processing environments, so that prevent drying or spoilage. Efficiency opportunities here. Again, many of the common opportunities apply, but more specifically, steam trap monitoring makes sense in these facilities. Retrofitting steam condensate recovery systems with automated filtration and reuse systems. Upgrading brewery and food processing steam systems with modular steam injection units. Implementing steam system integration with brewing and cooking processes for energy efficiency. Tuning control loops just to more properly control steam use, and metering and monitoring at key process points. Future of steam here. We're calling this a 9 also, and that's just based on, again, just the variety of uses and how kind of integrated steam is into the process of these facilities, as well as the stringent compliance and safety requirements that come with the food industry or anything that's made for consumer consumption. Now into textiles. This is another big steam user. They use steam for pre-treatment, so scouring, bleaching, and desizing of materials. Dyeing, they use steam to fix the dyes by opening the fibers up, and it kind of accepts the dye more thoroughly. Excuse me. Printing sets pigments after the application. Finishing improves the luster, strength, and texture of materials. They use it for washing materials, drying materials, shrinking, ironing, sanitizing, and sterilization. In particular, if you think about fabrics provided for healthcare facilities, this is a big requirement, as well as others, but even more stringent there. And then humidifying. So again, controlling humidity in processes, but also in the areas where those processes occur. Efficiency opportunities here. Again, we're talking about steam trap monitoring. Any of these manufacturers that have high run hours, high pressure steam lines, not super high pressure compared to power generation, say, but I guess you would say medium pressure. You're not talking about a 5-10 pound steam system. That steam trap monitoring starts to make sense in these facilities. And again, or I don't know if I mentioned this actually, but a lot of these manufacturers, if you don't have a fuel as a byproduct, they're just purchasing gas, and so they have a pretty healthy, fuel cost from an efficiency opportunity perspective. Another opportunity is to install flow metering on dyeing and finishing lines or other key processes. Recover condensate and flash steam from dryers and presses. Use modulating valves and VFDs for process heat control. Optimize steam tracing and reduce standby losses, or upgrade heat exchangers in pre-treatment and washing. Future of steam rating. This one's pretty high too, an 8. Steam's essential for various treatment processes and other processes in the manufacturing, and essential for cleaning and sanitation. We mentioned it's good for process control and quality control of product, as it's just a reliable temperature and or heat supply, and then safety and compliance. So there's stringent requirements for this industry as well. Maybe not quite as much as pharmaceuticals or food and bev, but again, still a lot of compliance opportunities, and steam is a reliable heat source for them. Lumber, pulp, and paper is the next facility. So typical uses here, you have power generation or cogeneration, digesting or cooking, which is where you're breaking down wood chips or other pieces into pulp. Paper drying, where steam dryers remove moisture from sheets. Excuse me. Heating used for space and process heating. Chemical recovery for regenerating cooking chemicals. Steam turbines, they actually use steam to drive machinery or supplement power, and cleaning and sterilization of mill equipment and product. Efficiency opportunities here, upgrade recovery and power boiler control systems, recover flash steam from drying and black liquor systems, filter and reuse condensate and digesters and bleach plants, optimize steam turbine operation for heat and power balance, and automate steam control for batch and continuous processing. These facilities are, some can be difficult to find opportunities. There's a lot of at larger mills, there'd be a lot of qualified people there focusing on the boiler plant and kind of know what the opportunities are already. And if they do exist, maybe it's just because of budget constraints or payback requirements. And so sometimes it can be difficult to walk in these facilities and find opportunities that'll move forward into a project. Also because they generally have very low fuel costs. So they're usually using at least some portion of their fuel is byproduct, if not all. So they have wood chips for biomass boilers. They have black liquor coming out of the craft mill processes. And they generally are paying, significantly less than your typical manufacturer for their steam, which is why you see the steam used in as many applications as possible, such as for mechanical drives and things like that maybe it wouldn't be used for in some other facilities. Future of steam rating here, a 10. So like I was just saying, because you have low fuel costs, steam is a good option. It just delivers large amounts of heat efficiently. They have high heating requirements. It's already integrated into core operations like craft mills. It's cogeneration ready, so they can utilize it to satisfy large power requirements at the mills and generate their own power. It's scalable. It's renewable friendly, so it can be powered by their byproducts like biomass or waste liquids like black liquor and recovery boilers. It has an efficient distribution. It's good for moisture control. It's proven technology. They've been using it for decades, uh, if not centuries. And there's good recovery potential for flash steam. And there's future flexibility, so they can, change fuel sources, or a lot of times they have boilers that have multiple fuel options, and they can switch based on what is most affordable at the time or what makes sense for them at the time. But yeah, steam in lumber, pulp, and paper is really not going anywhere. That with some exceptions for maybe smaller mills, might be considering other options, but generally speaking, these are really large steam systems. They're just integral to their process, and they will remain for years to come. Chemical and petroleum processing. Uses of steam here are process heating, stripping and distillation, tracing of product lines, cleaning, like flushing lines and sterilizing equipment, steam cracking, which is in the petroleum industry, is like breaking hydrocarbons into smaller chemicals, cogeneration, vacuum ejectors, humidification, and a dilution or reactant. So it acts as a medium in certain chemical reactions. Efficiency opportunities. Again, steam trap monitoring, especially in the case of the chemical facility, they're just buying natural gas and they have high pressure lines. They have critical processes. Steam trap monitoring makes a lot of sense, especially where it can comply with their hazardous locations that they may have. Uh, Improved process control, flash steam recovery, condensate polishing or treatment to improve reuse quality, rerouting or combining loads, metering and submetering, adjusting steam end use scheduling, or automating steam and condensate valves for intermittent or batch processes. Future steam rating in these facilities is a 10. It's just they have very high, a lot of these facilities anyway have very high temperature demands for a lot of their processes. And there's really, once you get above a certain point, um, you're kind of out of the realm of thermal fluid as an option. And there's just, it's just so integrated into their processes, or so required by their processes, that it's just not going anywhere in most of these facilities. It's essential for separation, for cleaning and non-contaminating, for sensitive processes, high temperature capability, cogeneration ready. I said it was deeply integrated, and then it's adaptable to clean fuels like hydrogen, electrified boilers, industrial heat pumps. They just need the steam, right? So if you can find a different way to generate the steam, then you can adapt these systems to that. I believe this is the last one, power generation. So obviously you're using steam for electricity generation. This could also be combined heat and power systems, where maybe they're using the steam for processes, or to send out to their clients as well in like a district loop. Um, Feed water heating. These are kind of more, some of these are like steam use in the boiler house, but feed water heating, preheating combustion air for the boilers, steam-driven pumps and compressors, soot blowing and boilers and heat exchangers. That's more for coal boilers and biomass boilers, where basically you're blowing off the coils using steam to clean the coils and maintain your heat transfer efficiency. Steam tracing and freeze protection for plant piping and equipment, vacuum injectors, auxiliary building and equipment heating. So those buildings supporting the plant, they're using steam for that, possibly. And then de-superheating and attemperation. Efficiency opportunities, steam trap monitoring. Again, replacing or optimizing steam-driven equipment or upgrading controls for steam end uses. Um, These are hard to find efficiency opportunities in often because, their whole business is generating power and is operating these boiler systems, and the people there really know what they're doing. But that doesn't mean that advances in technology don't lend themselves to projects here. And steam trap monitoring has certainly become something that is now more affordable, and makes sense if you have, kind of heavy potential losses on your traps, which these facilities definitely do. Future of steam rating, I'm going to say this is an obvious 10. Uh, you know, turbines are just steam turbines are based on the use of steam. Even when you talk about renewables and things that can still involve steam generation and spinning a turbine, is critical for nuclear power, which I believe is a big part of the future of power generation. And most nuclear designs involve generating steam and spinning a turbine. Um, and it meets growing demand, and it is proven and viable. And most power generation, with the exception of some renewables like wind and solar, but most power generation is happening with some version of generating steam, and then that steam turning a turbine. So I think steam is around for power generation for years to come. And again, the method of generating that steam may change, but as a medium, I think it's great. Okay, that's it for facility. So the conclusions and takeaways from the presentation. Steam is still a great medium, first and foremost. It's versatile, efficient, it's capable of meeting both heating and process demands across a wide range of applications. Steam remains a vital utility across many sectors, supporting essential operations from sterilization to power generation and everything in between. Many efficiency opportunities are common across different facility types, offering scalable solutions like trap maintenance, insulation, pressure optimization, and heat recovery. So you're seeing a lot of the same opportunities in different facility types, but the equation changes at each facility, right? Like what pressure steam are they on? How much are they paying for fuel? What's the condition of their steam system? Um, what are their maintenance schedules? All of these factors play into the decision making on what the best opportunities are. But you're seeing a lot of the same ones in different facilities. Future viability varies by sector. So you see that with our scoring, some facilities are transitioning to alternatives, while others will continue to rely on steam long term. Modernization efforts should focus on upgrading controls, right sizing equipment, and aligning with decarbonization and sustainability goals. Um, and strategic planning today ensures that existing steam systems continue to deliver value while positioning facilities for future energy transitions, such as um, advancements in generation technology. And that is it. I will stick around. It's 11:52 where I'm at. I will stick around until questions stop rolling in. But if you guys have any questions, feel free to put those in the chat and I will answer them to the best of my ability. But I do want to thank you all for joining before anybody drops off. And also, we have an upcoming showcase webinar. We have two really renowned experts on heat pumps, and they're going to talk about industrial heat pumps, which is going to be really interesting. We're going to have Phil Johnson and Clay Monahan at Atlas 602. Phil Johnson's at E4E Solutions, and they're both heat pump experts in the industry. And we're really excited about that. If you scan that QR code, you can register today. Also, you can just go to our website and register. And again, if you do want a PDH certificate for today's presentation, just email me at that email address there, and I'll be happy to send that over to you. And yeah, we thank everybody for joining.